How can I understand Linux kernel internals? Imagine a busy city with roads, traffic lights, and public services all working behind the scenes to keep everything running smoothly. The Linux kernel is like that city's control center, managing hardware and resources so everything functions properly. To understand how it works, start by knowing its main job. It acts as the core part of the Linux operating system, handling hardware like processors, memory, and storage. It runs in a special mode called kernel space, separate from where regular applications run, called user space. This separation keeps the system safe and stable. Focus on the core parts of the kernel. First is the process scheduler. Think of it as the traffic cop that decides which process gets to use the processor and when. It makes sure all processes get a fair share of CPU time, so nothing gets stuck waiting forever. Next is the memory management unit. This part handles all the memory tasks, including virtual memory, which gives each process its own private space to work in. It also manages physical memory zones and supports hardware features like direct memory access, which allows hardware devices to communicate directly with memory without involving the CPU. Then there is the virtual file system. Imagine it as a universal translator for different storage devices and file systems. It allows programs to access files without needing to know the details of the hardware or file system type. The kernel architecture is mainly monolithic, meaning most functions run in one large program, but it supports modules that can be added or removed while the system is running. This makes the kernel flexible and adaptable to new hardware or features without needing a full rebuild. The kernel also includes code specific to different hardware types, like x86 or ARM processors. This code manages low-level tasks such as handling interrupts, managing memory, and optimizing performance for each hardware type. System calls are the bridge between user programs and the kernel. When a program needs to open a file, create a process, or communicate with hardware, it makes a system call. The kernel then validates the request to keep everything secure and stable. Inside the kernel, you will find data structures like linked lists and trees. These help organize and manage resources efficiently. To get a better grasp of these internals, you can look at the source code, which is open for everyone to study. Reading documentation and tutorials can also help clarify how each subsystem works. Experimenting with kernel modules lets you add or remove features dynamically and see how the kernel responds. Tools like the file systems and sys show real-time information about the kernel and hardware, giving you a peek into its inner workings. Compared to other operating systems, Linux's modular and open design makes it highly customizable. You can tailor it for anything from tiny embedded devices to large servers. Understanding the kernel internals means knowing its main subsystems, architecture, system call interface, and internal data structures. By exploring source code and system tools, you can see how Linux manages hardware and processes, which sets it apart from other systems.